Good morning, I'm Scott Ugrin. My presentation today is on the analysis of inkjet printers by capillary electrophoresis for forensic purposes. Forensic laboratories these days are seeing an influx of forgery cases due to higher resolution in printer technology. Next slide, these two documents, a birth certificate and a check, were created on an ordinary desktop printer. As you can see, they look pretty much to the naked eye like the real thing. Because of this influx of cases, the laboratories are looking for a more efficient method. Today they use HPLC for differentiation and PCMS for aging. And so a new method is capillary electrophoresis. Capillary electrophoresis is actually a picture of an instrument that we have on campus here upstairs. It uses a small capillary you can see right here. The sample vials right there, 6x10 sample vials. Keep a buffer in one and sample in the other, and then the destination vials are on the right. The capillary will pump up the buffer to condition the capillary. At that time, it'll use a pump to introduce a sample. Once the electromagnetic field is induced across the capillary, the buffer is attracted to the right side of the destination vial, which carries the charged particles with it. It's a block diagram of the same thing, so you can kind of see what's happening. As they pass the detector, they're measured colorimetrically. The research that I looked at, they used 220 nanometers on UV distance detector. This is just another way to look at it. The different components of the sample are seen there. You can see buffer in between. That shows that they're separated as the buffer moves to the cathode or the anode. You can switch up in between depending on which kind of buffer you're using. Separation of the molecules is based on the charge to size ratio. I'll show you that later when we get into the compound imprinting. It's more efficient financially for the forensic laboratories because they actually already have capillary electrophoresis on hand. They use it these days in DNA analysis. It's very sensitive. It can separate DNA strands that differ by only a few nucleic acids. It requires only a few nanometers of the sample. Printer ink is made up of water, glycols, ethylene glycol, and proprietary pigments and dyes. Because they're proprietary, I was able to find the exact compounds that they use in each color. However, the cyan is triphenylmethane salt, neutral but low in size. Magenta is xanthillium salt. Xanthillium is a plant pigment, so it's very large and highly charged. For that reason, you'll see magenta comes out last due to the low charge to size ratio. And yellow is an ethoxylated acetylenic diol. It's a small, highly charged particle, so that will come out first. In the research that I studied, the sample paper that was extracted was only 0.8 millimeters in diameter. They extracted it from the paper using a homemade hypodermic needle of that diameter. You'll see later when we get into the advantages over HPLC, how that keeps the integrity of the evidence, requires less destruction of the evidence. And extracted, they used only 5 microliters of a background electrolyte solution. And you'll note the low volume and the low concentration of the reagents used. It's also a greener process. From there, the supernatant liquid was transferred to a centrifuge tube, spun down to remove any solid particles, paper particles, or pulp. And it was diluted with a 1:99 ratio of 5 microliters of the background electrolyte solution and then injected. This is their results page. It's a small database that they gathered based on printer ink cartridge on the right side and the printers that they used it with. One of the things they were trying to see is if they could differentiate both printer ink brand and the printer that it came from. As you'll see in the next slide, they weren't able to do that. They separated based on the elution color, the migration time of each color, and some colorless additives. This is the first 3 that you saw on the results page. Same ink cartridge, different ink brand. different printer brand. You can see the migration times are the same for all the peaks. The other thing they wanted to do is to be able to tell if they knew that a document was fraudulent, or that a piece of the printer was fraudulent. The piece of the print paper was fraudulent. They wanted to be able to tell which printer ink cartridge it came from. That's what's shown here. On the bottom, the electropherogram is a question document signature. To the naked eye, it looked like a blue ballpoint pen. However, when they compared it to their database, when they compared the migration time peaks to their database, they were able to tell that it was a brother ink cartridge. Next thing they wanted to do, if they didn't know whether it was fraudulent or not, they wanted to be able to compare it to the original if they had the original on hand. On the bottom here is the question document stamp. In the middle is the original stamp. You can see that the peaks do not match up. The spectrum on the top, they actually compared the spectrum to known dyes, and turned out to be a crystal violet dye, as opposed to the compounds present in the printer ink. They also compared that to their database and were able to match it up with a Canon ink cartridge. HPLC, like I said, is the method in use today. We'll get into a little bit into the advantages time-wise later, but basically HPLC works by, they use reverse phase HPLC. They pump a polar solvent through it, continuous polar solvent, most likely methanol, through a packed column. You can see where you inject the sample here. Through a packed column of a stationary phase, it's nonpolar particles. You can use either charge or size exclusion, and they'll separate based on their charge or their size if they have the same charge. From there, it goes through the detectors, and like I said, it requires a constant flow of solvent. As I said, you saw the small amount of sample needed for capillary electrophoresis, so it's much more green. Also, the sample size required. In HPLC research, they cut out a rectangle that was 0.4 centimeters by 1 centimeter, completely destroyed the evidence for any further analysis, as opposed to capillary electrophoresis, where you just poke out a little hole, preserves the integrity. It shows the higher sensitivity of capillary electrophoresis, and also, as I said, the less destruction of the evidence. Time advantage. The runs for HPLC require 35 minutes for each run, and that actually also includes a manual injection. Capillary electrophoresis requires